Before we jump into today's lesson, I wanted to address some concerns that many of you have raised about how to turn in the assignment. Just to be clear, there is no one specific way to turn in the assignment, but I will give you some suggestions and also provide a template for those of you who kind of want a better idea of how it should be turned in. So you should be writing your assignment code under the problem set 1 workspace that the professor created for you. So within that problem 1 set, you will have a code that looks something like this. And this is just an example I wanted to provide you as well. And this will be available in the discussion 3 problem set 2 workspace under turnin.r, which is right here. And what you want to do is put your name and any collaborators you worked with, and then you want to import your data. And I cannot stress this enough, but you should really be liberal with your use of comments, hashtags, which is a comment, in order to really delineate what you are doing. This is really helpful for you when you come back and look at it later in the semester, or perhaps even in the future if you want to be able to replicate what you did in R. So I highly recommend, writing these comments like import library, import dataset, and make it really clear. And then under that, I want you to put the problem number and the specific problem that you are answering. So in 1B, you need to show frequency tables. So just, write something like 1B frequency table for education and vote, and then include your code. Now, there's a number of ways you can actually put your code into your assignment, and I will show you a couple right now. But here, I will also show you the template that I will share with you, which is just a Word document for the assignment with all of the questions. And what you're going to want to do on this problem set as well is, of course, put your name on it, put your coworkers on it, answer the questions, obviously using the word processing in the areas where you don't need to use R code, which is, for example, in question A. But for the problems that require RStudio, there's, again, a number of ways you could put the data in here. And this is just a template that you could use. So you could see the output in your RStudio in the console area, right? So for example, let's just clear it out and run. If we were wanting to see the education by percentage, we would put, education number 1 right here, and then we would put the relative frequency, so the percentage here. Obviously, this doesn't apply because it's education, not vote, but I think you can get the picture. The other thing you could do, and I think some of you have done it, is just copy this here and pasted it in, which for me, I'm completely fine with as well. As long as you center it and put it in a table and make it a little bit easier to digest, as long as I can understand it, or I should say, as long as a frozen eye can understand it, the TAs can understand it, it's completely fine to do other styles as well, just as a heads up. So don't worry if you did it a different way, as long as we can, again, interpret it, it's okay. So you can do that. You can also export these tables as a CSV, as I showed in the last video, and then you can make a table in an Excel file and then copy that Excel file in. That's one way you can do it. But there is a specific way I want you to put in, for example, histograms and graphs. So, and there's actually a method to do that, which is a bit confusing in RStudio, so bear with me. When you do the histogram function, or run the histogram function, you will notice, as I pointed out in previous videos, that you can see the output down here. And so what you can do is actually export this, saving that image as a PNG file and labeling it whatever it is that you want to label. So just maybe answer 1C, and you save that. And then you'll notice that your answer 1C PNG is currently in your workspace, what you're going to want to do is click on it. So once the box has been checked for it, then you go to the More category here, More tab, and then you export it, and then you download. And then once it's downloaded to your desktop, what you can do is just drag that PNG in to your Word document. And then this graph's not exactly the greatest, but this is just an example. You can resize it and center it, and then that will be your answer. Of course, in this question here in C, you have to also answer in words one section, but just make sure that you put that histogram right here. So that's the way to download it. Again, you can really do it any way that you feel communicates the results. There's no one way, but really try to, in your code here, delineate which code belongs to which section of the question, just so it's easier for us to understand as TAs. And it's optional, but you can also add at the very end kind of a data appendix section to this, and that's just optional because we didn't tell you beforehand, but if you just say type data appendix here, and below it you can just copy everything in this code on the left side, and then you can just paste it in to the right side, then that can show your code in this document. But that's not 100% necessary because we can always go into your RStudio workspace and to check your code. So that was just a brief discussion of how to turn in your assignment. Again, sorry we didn't make it a little bit more clear earlier, but hopefully this answers your questions. And if you have further questions, please feel free to reach out. Thanks. Today we're going to go over the necessary code for problem set 2. I want to also cover something that I think many of you have been having trouble with when you access your workspaces. When you have a workspace in RStudio, again, all of your files will be located at the bottom right corner, so that will include your CSV files, whatever other files that you've created. So for example, like we just created that PNG file for the histogram, and it will also always include the R code that I write for these tutorials. And it's very easy to find that code because it's titled actually the same name as the workspace, but just .r. So if you open it up and you only see this and you don't see R code, that means that this has not been selected, this disk3_ps2.r file. And these R files are pretty easy to identify because they just have a little R here and it's a .r. If you don't see it, it's because you haven't clicked on it. So just give it a click, and then that will be exactly the material that I go over today. And as always, if you want to follow along with what I have here on the left side of this presentation, all you have to do is just follow this link, and it should bring you to that presentation on your own end, so you can go over it. So let's get into it. We are going to just do a simple import as we've been doing in all of the other assignments, but this time we're going to be using a CSV file called demo. So this is the actual file you're going to be using for your problem set 2. So let's just try to import that, run that line of code. It's blue, it looks like it imported. And you see it on the top right, it looks like it imported. And we can check it out by, of course, using that head code that I've taught you. So it looks like now this data set has a bunch of different country data, which is interesting. Then we will import the dplyr and ggplot packages as we have done, before. Make sure again that these are installed. I think some of you did not install the packages, and this actual line of code always needs to be before this line of code if you haven't installed it yet. And so it's install.packages, name of the packages, and then you have to run this line of code after. It has to be in this order. Some of you have also asked, do you need to install it every time? The answer is no. So if you have installed it and you click out of this workspace and come back in later, all you have to do is just run this line of code. So we will be learning how to create a scatter plot today. It's similar to the hist plot, but slightly different because we're going to now be including two different sets of data for x and y. The function is called plot, so it's pretty easy and intuitive. The first code you're going to put in will be the name of the data frame and then some column within that data frame connected, of course, by that $sign. And that first line will always be the x-axis. And then the next line of code will be your y-axis data. So it'll, again, be df and then whatever it is that you're interested in. So in this case, it's polity. And let's just actually type in the names function just to see what data we have, just to get a better idea. So it looks like we have country, polity 2, GDP, regime, and wealth. So we have those columns. And so I just access the polity 2 and GDP data from that data frame. And again, if you want to look at that data frame, you can just click here and you can open it up and see what's going on and see what the data is. So the next thing we have within this, sorry to get off track there, but just wanted to confirm that you know what's going on. The other things that you can do with this plot is do an X label, a Y label, you can do a main title, and then you can also, this 19 is actually, this PCH 19 is what produces the dots for the dot plot, and I will show you this line of code right now. And this is the output. It looks like it's a scatter plot. And so for your assignment, you can just go in and change this data, of course. The next thing we will do is the exact same thing, but using the ggplot library. Again, this stuff is optional, but I just want to show you that there's multiple ways to produce graphs. The df, so in 1.2 with ggplot, you use df, and then you use this operator here, and then you use the ggplot, and then you type in AES, which is just the name for the function. Don't ask why, I actually don't know. ggplot just decided to go with that. And it's a little bit more clear here in ggplot in some ways because you say x equals whatever it is, data that you want to set on the x-axis. So unlike the plot function, we don't need to use the $sign. You can just type in the column name. And for y, and then for the y, it's the exact same thing. You don't need to use the $sign. You just type in the name of the column. And then you use a plus, and then that creates the dots for the dot plot, and then our x and y labels are created like this. And so if you run that line of code, it more or less shows the same graph, but just in a different style, the ggplot style. And again, you can always export these and download them to your computer, as I showed you in the previous section of this video. So the next thing that we're going to do is to do correlations between two different columns. And it's rather straightforward. It's just this core function. You put in one set of data by typing the name of the data frame. Again, you type that $sign to access some column that you're interested in. And for correlation, you want to look between the correlation between two columns. So then we just do a comma and the second column that we're interested in by the same method. And then we run this line of code, and it will show you below the correlation. So let's do that again. And again, that correlation is down there. 2.2, again, is optional like before, but it's using dplyr. And the code looks a little bit similar, but just a little bit different because it's in dplyr. You say the name of the data frame, you use the pipe operator, and I should have mentioned this far before, but the pipe operator on a Mac, if you want to have the shortcut, it's Command-Shift-M, and then it's just a lot easier to create the pipe operator. For reference, and then you use the select function, and we're selecting GDP and wealth. And I can just show you what would happen if you only did that. rather than include correlation, if you just did the select, it would just select those two columns. But because we're going to add the pipe operator with Command Shift M and core, it will actually just show us the correlation. You see here that's the correlation. Now we will go on to histograms and filtering. There's actually a couple ways you can do this as well. The first way you can do is by writing the name of the data frame, and then in brackets, you write the name of the data frame and then the column that you're interested in. So in this case, we're interested in the regime column. And then if you want to only access one part of that data, so for all regimes that are category 1, you just say equals to 1 and then a small comma, or just a regular comma, excuse me, there. And then you can actually save that new data frame as a separate data frame, which we'll call autocracy.df. And then you'll notice that in the top right, that also comes up. So let's take a look at what we just created. The autocracy.df, as you'll notice, kind of looks like our data frame. But if you look at regime, it's all ones, whereas before, there's different regimes in all of the data, right? So what that does is just copies all of the rows that are of the regime 1, and that will be called autocracy_df. You can also do the same with democracy, right? So it's the similar pattern, but instead of regime equals to 1, it will be equals to 3. So let's do that. Let's look at the democracy data frame, and what you'll see is that all the regimes are 3. Okay? Now, we can actually, of course, just take a look at that with the head function. You can use the head function in dplyr using the pipe operator as well. I think you'll maybe notice that the pipe operator just allows to access a function. So in this case, it's the head function. Rather than writing head and then the name of the data frame inside, you just kind of tack it on there with the pipe operator, and then head 2 will show the first 2 columns, and it'll show that new data frame that we created. The other way you can do this creation of new data frames, or the filtering, I guess I should say, is by using unsurprisingly, it's named filter in dplyr, and that is you just write the name of the data frame, you do the pipe operator. This time, rather than select or summarize, which we have used before, we will use filter. And then I think this is a little bit easier to understand than this up here, because you just type in the name of the column that you're interested in. So again, regime is just a column that we have here in our original data frame. And you just say equals to 1, you write equals to 1, and then if we wanted to show the first 2 rows of what that data frame would look like, you could just add the head, and then it would be the exact same thing. If you got rid of the head, it would show the whole entire data frame. But I think you'll notice that it printed off the whole entire data frame, which we actually don't want. So if you actually wanted to save that, there's a very easy way to do that. And this probably shouldn't surprise you given the last videos I've created, but all you have to do is run this exact same line of code. Actually, this is not the right one. You run this exact same line of code, and then before that line of code, you put an equal sign and then the name of this new data frame that you're going to make. And then that will also save a data frame exactly how we did up here. And if we wanted to do that with democracy, we would just do democracy_df equals, and let's actually name it, we can just name it dplyr just to confirm that what we're doing is right, and then df, pipe filter regime equals to 3, and it should give us a data frame that looks almost exactly similar to what we had. It is exactly similar to what we had in the code before. Now we will look at histograms and making more than one at a time, kind of putting it side by side. Oh, I'm sorry. I realized that this actually I was not following along with my presentation that I made, but let's just go over it quickly, I guess. To review, we imported our data, we imported the packages. Again, make sure that you have installed these libraries, and that needs to go above it here. When you're doing the scatter plot, the function is plot. The first line will be our x, the second line will be our y. Make sure that you have commas here. If you don't, there will be an error. The other way you can scatter is through ggplot, as we saw before. And this is exactly the code to do it. But unlike the plot function, with ggplot, you don't actually have to say the name of the data frame. You can just write the name of the column for these x and y variables. For a correlation in 2.1, all we did was use the correlation function. And again, accessing the columns using the $sign, making sure that we have a comma between there, and then we run it and we can see the correlation. You can also do this in dplyr by using the select function and then the correlation function. And then in 3, we went over how to filter, so to get only certain rows that you're interested in seeing. So there's 2 different ways to do that. It's by using these methods right here, which is df, and then in that df brackets, you include the name of the column that you're interested in seeing, and you're filtering by, the exact category that you're looking to filter by. So in this case, it's regime equals to 1, and we name that a different data frame. We also created a democracy data frame, and we did the same thing with dplyr here on the left side by using the filter function, and we also saved that. And I will update this here because there's a little bit of a discrepancy, but I think you get the picture of what we're doing. And then now that we actually have those filtered data frames, we can use those data frames to make histograms, which will answer the question of how to make 2 separate histograms, but place them side by side. So it's just actually pretty easy with the hist function. You just write this line, so par, and then mf row equal to this, which means 1 row, 2 separate columns. The first row, we're going to use the histogram, and we're going to do the polity2 data from our democracy data frame. And the second histogram, we're going to use the autocracy data frame, but the exact same data, or the exact same column. So it will show you the difference between democracy and autocracy for polity2. And I did not do it correctly because I forgot to run this line of code. So make sure you run all 3 at once, and then you will get the code side by side as I have here. Now you can also do this in ggplot. It's a bit involved, so if you don't want to see how it's done, don't worry about it, but I will just show you. You're going to use another external package, so you're going to have to download this grid.extra. So after you install it, you're going to run that library, and then this time when you run the ggplot, it will be similar to what we did before. So you do ggplot, AES, and then what you want to see for the data. So you put the column name, and then this time we're going to do geom histogram. So that's the difference. This time from before, we used the geom. We used the geom point, right? So it's obviously different. This time we were looking to do a histogram, and we actually save that as an object, and that will be from the democracy data frame. And then we will do the exact same thing down here, but for the autocracy data frame, and the same exact data for the histogram. And then we will use this grid.arrange function, and it will put all of them together. So make sure you run them all at the same time, and you will see that we have a histogram. And bins is the number of bins on that histogram, so feel free to play around with that. The last, well, actually, this is not the last thing we'll cover, but we will be looking at two-way tables now, which is corresponding to problems 2F and 2G in your problem set. You're going to do a frequency table. So it's just the exact same thing before, the table function that we used, but this time we're adding another set of data. So the frequency data will be spit out as column and so this on the left side will be the column and this on the right side will be the row, and I'll show you what that means in 1 second by running this. So that wealth category will be these columns, so wealth number 1, 2, 3, and the regime data will actually be the rows, so the regime 1, 2, 3, and we can actually rename those by using the row names and column names functions. So after we've saved this frequency table, as you'll see here we have it saved, you will do row names, and inside we will put that saved frequency table, and we can actually name it a little bit more clearly. Regime 1, reg 2, reg 3, and then wealth 1, wealth 2. I think you get the picture by now. Wealth 3, and you run that, and when you run these lines of code, you'll notice that nothing really changes, but you'll see blue, which is a good sign, which means that the changes were made. And then once you've run that data, we want to recheck our table, and now it will have that data. So we successfully created a table with names. And like before, if we want to see the percentages, all we have to do is use the prop.table function, and then within it just put that frequency table that we have saved, and it will give you the percentages. Now if you want to see the percentages by the columns, all you need to do is use that. And so now we're in 4.3. Let's scroll down here. Now we're in 4.3. What you want to do is show the prop table again, the frequency table inside, and all you do is comma 2, and then that will show you the percentage of the observation based on the column. So the columns should all add up to 100. So wealth 1, that plus that is 100. These three columns, 100. These three columns is 100. And that will just give you the conditional probability. So 4.4, now we're going to make a two-way table using dplyr. So it's exactly what we did before. We will use the select function, and then using that pipe operator, we're just going to put on the table function. It's more or less the same process. We'll give you the same outcome. And if we wanted to see the percentage of the total observations, we would do that same exact dplyr function, but we will just add another pipe operator and then add that prop.table. So you can see that it's all of this is doing with the pipe operator is just allowing you to add more functions. So the first function we use is that dplyr select, and then the table is actually not dplyr, but with this pipe we can add that table function, and then with this other pipe we can add the proportion. And so that shows us the proportion. So we covered quite a lot today. I highly recommend you reach out to me, or excuse me, before you reach out to me, please try to attend the Thursday 2 p.m. sessions for TA. I'm always happy to answer your questions, but if you attend those, then you can potentially just ask me during that time. If you can't attend during that time, but you still have a question, try to ask the question on the perusal, because I think when you ask those questions, other students can see, so they benefit, and then other students might be able to ask, so try those things. If you have other questions about how to code, you can always use Google. And then, of course, I'm always here to answer questions. If you're having a lot of trouble with R, please book an individual session with me. I'm happy to spend 15, 30 minutes with you going over any issue that you're having with RStudio Code, or just to go over any questions that are lingering from the problem sets. So again, thank you for giving me some feedback after the first couple of videos. If you're hoping that I do anything differently, feel free to reach out. And if you have questions, again, as I said for the millionth time, feel free to email me and to set up a time for us to go over it together. But anyways, thank you, and I hope you're having a good first couple weeks. Cool.